Hi guys, welcome to this set of videos. All of these videos are going to follow along with the notes section that comes out of your textbook from Chapter 5, Section 2. Now what we're doing here in Chapter 5 is we're talking about polynomials, and in the first section, hopefully what you may have noticed is we started talking about operations of polynomials, but we only looked at 3 of the 4 operations. We looked at addition, subtraction, and multiplication, but we didn't talk at all about division. And that is because division is a little bit more complicated and certainly worthy of its own section. So here's what we're going to do. Chapter 5, Section 2, all about dividing polynomials. So before we jump into this, let's go ahead and give you your 2 objectives or learning targets. You're going to need to be able to do 2 things by the time we get to the end of this set of notes or these videos. You're going to need to be able to divide polynomials using a method that looks, and I apologize, there's a slight typo here, that looks very similar to the long division that you did back in middle school. However, we're not going to call it long division here, or we shouldn't. We shouldn't call it long division. Let me just scratch that out. And instead, we're going to call it what's known as algebraic division. Okay, it'll look very similar to long division, and some people may call it long division, but it is not long division. Long division is what you did in middle school when you were dividing really big numbers and you set up your dividend under the long division symbol and you divided by the divisor and you did all that stuff. And I'll refresh you, or we'll review all of that with you. That's long division. What we're going to be doing has variables in it. And so it's not the long division from middle school, it is algebraic long division, or just algebraic division. And then the second thing we're going to look at, because the algebraic division is a little tricky, there is a shortcut, but I don't want to show you the shortcut first, because then all you'll ever use is the shortcut plus a little nuance here to the shortcut. We're going to use what's known as synthetic division. However, synthetic division does not always work. There are specific cases where synthetic division will work. There are some cases where synthetic division does not work. So we'll show you when synthetic division works, and then whenever synthetic division doesn't work, you're stuck. You don't have a choice. You've got to do the algebraic division. So we're going to look at both of those, starting with the algebraic division, and then we'll show you the cases where you could possibly use the simpler method known as synthetic division. But before we do any of that, let's just start off with the really easy stuff, which is this. Dividing by a monomial. Now, you're going to recall from Algebra 2, I apologize, from middle school, there were a couple of ways that you could do the division. So if you were using numbers in these 2 example problems, if I had 15 plus 6 plus 24 divided by 3, what you could have done is taken 15 plus 6 plus 24, which of course is 45. And then simply, once you've added your like terms, divided by 3. So 45 divided by 3 is 15, and you've got your answer. Now, here in algebra, this one's not going to work. Your numerator will not have like terms. So this particular method for doing division by a monomial isn't going to work, right? Because you're not going to have any like terms. If there were like terms, they would have already been combined or put together. So there's not going to be anything for you to add together and then divide by, but that's okay, because there was actually a second method you could have used, and hopefully you remember this from middle school. Instead of adding 15 plus 6 plus 24 to get 45, what you could have done was this. Split each of the numerators up. Make each of the terms in the numerator its own fraction by your common denominator. So you could have done 15 over 3 and gotten 15 divided by 3. 6 over 3 plus 6 over 3. And 24 over 3 plus 24 over 3. Now watch the way this works. 15 divided by 3 is 5, 6 divided by 3 is 2, and 24 divided by 3 is 8. 5 plus 2 plus 8 is 15. Please notice, you get the exact same answer doing it two different ways. Well, this one's not going to work because you're not going to have like terms. But this one is going to work for us, where you take that numerator, you split them up, and put each of the terms in the numerator over that denominator. So let's go ahead and take a look at how this is going to work in one of our example problems, where now instead of just numbers, we go ahead and do that algebra thing and throw some variables in there. Okay, so I take a look at my numerator, and again, I don't have any like terms. 10x to the fourth, 8x cubed minus 12x. Yes, they're all the same variable, but they're not all to the same power. So they're not like terms. So what we're going to do is use that method. In fact, let me just scoot it up a little bit so you can still see it right there. This is the one where we take everybody in the numerator and write it over top of the denominator. So here we go. I'm going to now have a 10x to the fourth divided by 2x plus 8x cubed divided by 2x minus 12x divided by 2x. Well, now what I can do, right, is I can now cancel top and bottom anything that's common, reduce my fractions, right? Now, I couldn't do that here, right, because you can't cancel through addition or subtraction. 15 plus 6, right? I got addition there. 6 plus 24. I've got addition in there. I can't cancel through addition or subtraction. But what I've done, since I split all of these guys up into their own separate fractions, right? Now everything in the top is connected by multiplication. 10 times x to the fourth and 2 times x. That's all a product there, a numerator. Everything in the first term is a product. Everything in the denominator is a product. And now I can cancel through multiplication. Same thing here. All I've got in this top term is multiplication. Multiplication in the bottom term, so I can cancel, right? What I've done is I've solved that problem where you can't cancel through addition and subtraction. I've written each of the fractions, or I've written each term in the numerator over a common denominator, and now we can cancel top and bottom. So here's what we've got. 10 divided by 2 is 5, and x to the fourth divided by x, x cubed, plus 8 divided by 2 would be 4. X to the third divided by x. Again, and I'm sorry, I should have mentioned this. We're going back to that section 1, the properties of exponents. Remember, anytime you have a like base, you simply subtract the exponents. 3 minus 1 is x squared. So you're left with an x squared. 12 divided by 2 would be 6. X to the first divided by x to the first, which means you have 1 minus 1, which is 0. X to the 0 is equal to 1. Anything raised to the 0 power is 1, so that's just going to be a 6. There is my new polynomial, which I get by doing that monomial division. All right, let's try a couple more of these. I think I got a couple more here on the next page. Try a couple of these easy ones before we move on to something a little trickier. Okay, so here again, what you guys are going to do is we're simply going to take everybody in the numerator, write it over top of my common denominator so that I can then begin to cancel. All right, so here we go. Plus minus okay, here we go. Let's go ahead and cancel, simplify as much as we can. 6 divided by 3 is going to be 2. X to the fourth divided by x leaves me with an x cubed, and y cubed divided, so y squared. Awesome. 12 divided by 3 is going to be a 4. That's going to leave me with an x squared and a y. And then negative. 18 divided by 3 is going to be a 6. X squared divided by x leaves me with just an x, and y divided by y, the y's will cancel each other out. I don't have any y's left, and there is my new polynomial. You guys are on a roll. Let's keep going. Okay, written slightly differently, but still doing the exact same thing. I have my numerator, right, this trinomial, divided by this monomial, right? It's just written a little different, but it's the exact same thing as before. So I'm going to take each of the terms in my numerator and divide them by my common denominator, right? So even though it's written a little differently, you should still recognize it as division by a monomial. So that's going to get divided by 4CDF minus 16CDF squared divided by 4CDF. And here we go. Let's go ahead and do that division. 20 divided by 4 is going to be 5. C to the 4th divided by C cubed. D, the F's cancel each other out. 16 divided by 4 is going to be 4. C's cancel. D's cancel. I'm left with just an F. Man, I love it when stuff cancels. And then here at the end, 4's cancel. C's cancel. D's cancel. F's cancel each other out. What I'm left with is not a 0. You're left with a 1, right? Cancel, 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 cancel. What you're left with then is 1 over 1, which is just a 1. That is not 0. Not 0. It's 1. Everything is canceled. Anything divided by itself is equal to 1. So there's my new polynomial. And let's keep going. Once again, written just slightly differently, but you should recognize it. It means the exact same thing. I've got this guy right here raised to the negative 1 power. Well, you know that if it's to the negative power, you simply take it to the denominator and change the sign of the power. So actually, let me show you what this one's going to look like. I would have then my 18x squared y plus 27x cubed y squared z. Okay, so that's my numerator, right? That's that first polynomial. And then I'm multiplying by this guy, but it's to the negative first. Well, to get rid of that negative exponent, I take it to the denominator and change the sign of the power. So now that's going to be a 3xy to the first power. But because it's to the first power, I don't have to write, right? I don't need to put that in parentheses to the first power because anything to the first power is itself, right? So again, all this is just another way of writing this without actually writing it. So you guys know we're just going to go ahead and split these guys up. And we go ahead and do that division. 18 divided by 3, 6. It's going to leave with an x. The y's drop out. 27 divided by 3 is going to be a 9. It leaves me with an x squared. Leaves me with a y and a z. And so there's my new polynomial. And then this last one written exactly the way that you would expect it to be written. It's just written in your standard old fraction form. So let's go ahead and split these guys up. Okay, now that I've got them written as their own fractions, we go ahead and simplify each one of these. 5 divided by 5 is 1, so that's going to leave me with, actually the b's cancel, I'm left with just an a. 15 divided by 5, that's going to be 3. The a's are going to cancel, I'll be left with a b squared. 10 divided by 5 is 2. I'm going to be left with an a squared and a b to the third. And there is my polynomial. All right, guys, so the way that this works, this is division by a monomial anytime you have a single term polynomial in the denominator. You're simply going to take everybody in the numerator, split them all up, and put each one of them over top of that denominator, and then simply simplify those fractions using the properties of exponents that we learned in section 1. However, The division gets quite a bit more complicated when we move on to polynomials that are not, right, division that is not by a monomial. If we move on to division of polynomials that are binomials, trinomials, right, bigger and bigger polynomials, the division gets slightly more complicated. So the next page of notes, we're going to take a quick just sort of review of how you do long division from middle school, because we're going to use that as our model for algebraic division. So head on over to the next page of the notes, and I'll meet you guys there.